Welcome back to the channel. In this video, let's focus on thermodynamics. So I want to focus on the concept of thermodynamics, what thermodynamics is all about, the definition, and those quantities you must consider when you're studying thermodynamics. Then I want to look at what the basic concepts. So when you are studying thermodynamics, there are some things you must know in order to relate to questions or what they are saying when it comes to what thermodynamics. Then I want to look at what two key things, that the concept of what of work, where work is done, where work is done by the system or work is done on the system. They want to look at what the concept of what of it, the exothermic and what endothermic. They want to look at what the internal energy, change internal energy, and some of the calculations. So it's going to be a lengthy video. What I want you to do is make sure you stick to the end of this video, take everything step by step. Now, by the end of this video, you should be able to solve some questions related to what I want to do in this video. So make sure you like and subscribe if you have not done that, and share this video to people who you think need this video. Let's get into it. First, what is thermodynamics? Thermodynamics is study of heat or any other form of energy into or out of the system as it undergoes chemical transformation. So when we talk about thermodynamics, you're talking about what heat flow. Do that heat flow. Now, when a chemical reaction occurs in a system, there are two things that can be done. Now, it is either what flow out of the system, or it is what is flow, or it flow into what the system. So the study of flow of it into or out of the system as it undergoes what chemical transformation is called thermodynamics. So if for example now you consider a portion here, this is what the system. Now when the system undergo what chemical changes, like what I say, there are two things that will happen here. It is that what flow out of the system, or it is what is flow into what the system. Do you get that? Now, the study of how it is flow out or into the system as the system undergoes chemical transformation, that was called thermodynamics. And when you're evaluating now when you're studying thermodynamics or evaluating a system, there are some certain properties you must take note of. Like for example, now the first one is what is pressure. You must consider what pressure. You must consider pressure when you are studying thermodynamics. Number two, you must consider what a volume of that system. Number three, you must consider what the temperature of the system, then concentration of what of those systems. So you have to look at those things very well. Now, before we move further, let's look at what the basic concepts of what thermodynamics. Now, when you study thermodynamics, there are three things you must note. One is what the system. You cannot study thermodynamics without the knowledge of system. Two, the surrounding. Three is what? Boundary. So these are the three things you must take note of. So what is system? What is what surrounding? What is what boundary? Now, take down system. System is the portion of the universe which is under thermodynamic study. That was system. System is what that portion of the universe which is under what thermodynamics. So it is where the reaction takes place. They call system. So when you look at this one here, imagine we have this stuff here, this cylinder or beaker or any other thing here. So now let's just say the board is what's my universe. Now that portion of the universe which I'm studying is called what system. So system is the portion of the universe which under thermodynamics was studied. Then what is what surrounding? Surrounding is what the entire what the rest of what of the universe. Now, so everything outside this system is called surrounding. So here we have surrounding the system. The rest one is what is it was surrounding. Surrounding. Do you get that? This one is what surrounding. Then what is what boundary? Boundary is the real or imaginary surface that separates the system from the surrounding. Do you get that? So that point that separates the system from the surrounding is called the boundary. You have to take into account all this in here because the boundary defines the type of system you have. Do you get that? The boundary defines what the type of what system you have. So before we look further, let's look at what type of system. Do you get that? Type of what system. What is type of system? Remember, I told you that system is the parts of the universe which is under what thermodynamic study, right? Then the boundary is what separates the system from what surrounding. The surrounding is what is in the rest of what of the universe, which are not what considering. So look at what type of system, types, types of system. So now basically we have three types of what system. The first one is what isolated system. Isolated what system. Number two is what closed system. Then number three is what open system. Do you see that? Then we still have other one that is considered as they call adiabatic system. Now you have to what consider what these four types of system because they normally ask it in the exam. Now, before we move on here, now we talk about thermodynamics and the system. Now, there are two things that will happen to the system. Now, now there's an exchange. Now that we talk about the thermodynamics here, there's always what exchange of a energy. I get exchange of what of energy. It can also be heat. Number two, matter. Do you get that? So in the sense that remember, I tell you that the system is part of the universe which other thermodynamics do you get that? And the system normally interacts with the surrounding. Now, how does it interact with surrounding? It interacts with surrounding by exchange of energy or what matter. Do you get that? Energy or what of matter. So it can either what flow into or out of the system. Do you get that? And matter can be exchanged between what system and what and the surrounding. So in the sense that so that what now what about what isolated, closed, open, and what adiabatic what system. So now the type of boundary is what defines this type of system. The type of boundary. So we have two main type of boundary. Do that. Types of boundary. Types of boundary. I get. Now we have called two main type of boundary. Now these two main type of boundary define the type of system we are going to get. So one is what insulated boundary. Insulated what boundary? Now, what do you understand by insulated boundary? Number two, you have closed boundary. Remember, what is a boundary? Do you get that? A boundary is what separates the system from the what surrounding. If, for example, here we have a system here, what separates the system from the what? What separates the system from the surrounding is called the boundary. Do you get that? So that portion that was separate the system from that separates the system from the surrounding is called what? The boundary. And the boundary can either be two things. It can either be insulated boundary or closed boundary. The word insulated, what do you understand by the word insulated? Remember, in physics we have what we call conductor and what an insulator. Insulator is going for that word insulator. Remember when we talk about conductor can transfer heat or electricity, right? Like a conductor. But insulator cannot conduct electricity and what and heat. Do you get that? So when we talk about insulated boundary, remember I told you that there are two things the system can exchange with the word surrounding, right? One is what? Is energy. Is what? Energy. And when I talk about energy, I'm talking about what? Heat. Understand this? I'm talking about what? Heat. Number two is the what? Matter. The quantity of those matter in the word system. So now, when the system is insulated, please check it out. When the system is insulated, there is no exchange of what? Energy. Look at that. There is no exchange of what? Of energy. Because the system is, because the boundary is insulated. Remember, insulator, they cannot conduct heat and electricity, right? So when a boundary, that is the coverage here, when a boundary is what is insulated. That is, it cannot conduct it or what electricity. So there is no exchange of energy. So when the system, when the band is what insulated, that is, there is no what heat flowing in or what flowing out of the system. Check that. That we call insulated what boundary. Then we talk about close. Now the boundary is what is close. Now when the boundary is closed, that is, there is no exchange of what of matter. So when the boundary is what is insulated, no exchange of what of energy. When the boundary is closed, no exchange of what of matter. So there are things you must take note of. Now we talk about isolated system. There is no what exchange of what matter and energy between the system and the surrounding. So you must take on here. No exchange. No exchange of what of both matter and what and energy between the system and the surrounding surrounding. Are you there? Between system and what surrounding, very important. Do you get? So why? Why is that there is no exchange of both matter and energy? Now the reason is that reason the reason is because the boundary the boundary the boundary is both the boundary is both close and insulated. Do you get? So you say that what I want to understand here is that in an isolated system, there is no exchange of both matter and what and energy between the system and what surrounding. That is, there is no exchange at all. Now the reason is because now the boundary, remember that the nature of the boundary define the system, define what the system is going to be all about. So you say that the reason is because the boundary is both sealed and what? It's both closed or sealed and what? And insulated. So when a boundary is both closed and insulated, it's called what? Isolated system. Now, the next thing you want to look at is what? Is what? Closed system. Closed. Number two, closed system. Now, what is by what? Closed system. A closed system is a system in which what? There is no exchange of what? Matter, but there is what? Exchange of what? Of energy between the system and the surrounding. So you say that there is no exchange of what of matter. There is no exchange of what of matter. There is no exchange of what of matter, but exchange of what of energy between the system and the surrounding. Between the system and what surrounding. Now, you say that when you talk about closed system, the system is closed. The boundary is what is closed, but not insulated. Unlike the what isolated system, where the system is both closed and insulated. Now, here the system is only closed but not insulated. Do you get that? So when a boundary is not insulated, there can be what exchange of what energy between system and surrounding. But so that is why in a closed system there's not exchange of what energy. There is no exchange of what there is what exchange of what of energy, exchange of what of energy. Do that in a closed system. Do that, but no exchange of what? No exchange of what? Of matter. Do you see that? The reason is because the boundary is what is not insulated but is closed. Just down. So that I call closed system. Now, what about open system? Open system, actually open Open system. What do you understand by open system? Now, an open system is a system that there's exchange of both matter and what energy. So now I'm talking about open system. There, there is exchange, both exchange of what matter and energy. There is both exchange of what matter and what energy between between the system and the surrounding and the what surrounding. Do you get that? So that why is open. So I believe you are gotten the type of system. And then number four, adiabatic. Adiabatic system. Now, what do you understand about adiabatic system? Now, when you talk about adiabatic system, now you're talking about what? Thermal energy. Thermal energy. Thermal energy. The word thermal what energy is what the key point. So there is no exchange of what thermal energy between the system and the surrounding. There is no exchange of thermal energy between the system and what surrounding. So now you want to take data points from here. Do you get that? So let's move to the concept of what work and eat. Work and what and eat. Work and eat is one aspect of thermodynamics you must fully understand in order for you to what get what I'm talking about. Now, if you don't understand what you call concept of what work and eat, especially what work, now you may not understand some certain questions you'll be asked in what in your exam. So I want to what explain concept of what of work and eat when it comes to what thermodynamics. So if you ever pick concept of work, now let me know what concept of what work. So now we're talking about concept of work. That there are two things that can happen to a system. Now, there are two things that can there are two things that can happen to a system when it comes to what work. Work done by the system. Idea. Work done by the system. Work done by the system. Work work done on the system. So now you must understand the difference between two of them. You get so many people don't understand when work is done by the system and work is done on the system. So I want to explain that concept for you so that you're able to understand better. You get because there's actually a confusion when it comes to what this aspect of what thermodynamics. So now before I start explaining so here, I would going to draw a diagram. Look at the diagram here. And look at a diagram. So we have two diagram here. Now here we have this one. Now here's what is what external pressure. External this one means for external pressure. And here we have this one here. The external what pressure. External what pressure. So here we have two diagram here. So here I have this arrow here. And here we have what this arrow here. This is that. Now when you look at this one here, you can see that the pressure is going down. This that pressure is what is going down. That is now the pressure is acting against the system. The pressure is acting against the system. So what this is called work done on the system. It's called let me put it here. Work done on the system. Now because when work is done on the system is now the pressure is going down. Idea that is there's an increase in external pressure. Now when it's going down, you can see that the volume, because here we have volume. This is that here we have volume. Because that the volume is what is decreasing. Do you get that? Now whenever a volume is decreasing, when work is done on the system. We say what is compression. I there. Say what compression. Please take note of it. Call what compression because work is done on the system. That is, the volume decreases. Do you understand that? The volume of decreases. Understand here. Work done on the system. That is, the pressure is acting against what the system. Remember, this is a system, right? So work done on is called what? Compression. Now, on the other hand, here you can see that the system is going up. Again, you can see what the volume here. This is called volume. There is what an increase in volume here. This is that. So this one is called work, sorry, work done by the system. Work done by the what? System. Now, and whenever work is done by the system, now you can see that the volume is expanding. The volume is what is expanding because the system is acting against what? External pressure. Do you get? So you can say is what is expansion. Expansion. Do you get? You can say that expansion is what is going on here. But here where it's called compression. So there are two things here that happen to a system. Do that. Now, either work is done by the system, like work is done by the system, like for this one here, work is done by the system, or work is done on the system. So there are two things you must take note of. So please, you can take these two things down. It's very, very what important. So work done by the system is expansion. Is what? Expansion. Sorry. So work done by the system is what? Is expansion. Then work done on the system is what? Compression. Okay. Now, one is positive and what one is negative. And this is where students normally what get confusion on. Because now the sign you denote when doing work here is very, very important. So I'm going to write this place. I believe you have copied it out. So now let's take the expansion work first. So let's take the expansion work first. Let's take what the expansion work. Expansion work. Okay. Now let's focus on this one here. This is where work is done. Work done by the system. Okay. Now, when work is done by the system, what happens here is that the system is losing work. Right there. So the work in the system actually what to reduce. Because why? Because imagine you are having you are using your energy to do work. What are you doing here? You're actually what losing work. Your work is going to reduce. Do you understand? So now we're going to talk about expansion work. Now, work is always what? Negative. Do you get? Work is what? Negative. Understand here? So take this key thing down. When a system expands, it does work on the surrounding by pushing against an external pressure. The system internal energy decreases as it transfers energy in form of work to the surrounding. To account for this energy transfer, a negative sign is used to denote work done by the system. To denote what work done by the system. So now when I talk about expansion work, that is volume increases from initial to what final. So here we have W is equal to minus P change what in V. Now this change in V is what? V2 minus what? V1. Do you see that? So this negative sign here means what? Is expansion. That is, the system is losing work. Idea is what is losing work. So that why is what is negative. Now this P is what? Is my pressure. Is what? My pressure. I must be in what? In ATM. Then V is what? My volume. My volume. I must be in what? In dm³ or what? Or liter. You must understand these things very well. So now when work is done by the system, it is what is negative. It's very important you want place negative here. This negative here shows that the system is what to do the work. So there's a decrease in what internal what energy in the what in the system. So that decrease in internal energy, like internal what work is done on the what surrounding. Do you understand? So that this is when work is done by the system expansion. Expansion, the system is expanding. Work is being lost by system to the what to the surrounding. Do you understand? Now, so you also have work when work is done on system. Compression, compression, work work done on the what system. Work done on the what on the system. Now when we talk about work done on the system, what do you understand here? Remember, it's compressed. There's an increase in what in the what work done in the system because work is done on the system. Now when work is done on the system, my W, which is what work done, is equal to plus P change in what in V. Now this position is saying that work is increasing in the what system. So there's an increase in what internal energy of the system. Do you guys? So that's why work is positive here. So in the same here, so the only thing that differ between expansion and compression is the sign. Is the what sign? Work done by the system is expansion is what is negative. Work done on the system is what compression is what and is positive. Do you understand? So here we have two things. We're talking about concept of work. So here we have W is equals to what minus P change what in V called expansion. Expansion. Then here we have W is equals to what plus P change in V called compression. Compression. This is that. So you must understand this thing here. Just now, we have to solve problem here. So now, if you want to solve calculation here, remember that pressure is what is ATM, volume is what is liter or DMQ. Remember, the work must be in joules. Do you get? When you solve this one here, it's going to be ATM liter. Do you get? ATM what liter? So you have to convert ATM liter to joules. To what? To joules. That is where you need this relationship here. 1 ATM liter is equal to 101.33 watts. Joules. So I want to use this one in our calculation. We have to use one in what in our calculation now. When we continue, you have to understand what this concept very well. But take some time. So understand that now when you use the values of pressure and volume given to me here, look at now the work is going to be in what ATM liter. But however, the work cannot remain in what ATM liter. If you should live like this, if you live your answer like this, you are going to fail it. So you have to convert what ATM liter to what to joules. And the relationship is this: 1 ATM liter is equals to what 101.33 watt joules. Just that, so you need to take it of it. So let's look at what concept of it. Concepts of what of it. Right there. Now when it comes to it can either flow out of the system or it flow into what the system. So here we have this one here. Now here we have this one here. When it is what is flow out of the system. Now whenever it is flow out of the system, it's called exothermic reaction. I get exo. Exo means what? Loss of what? It. Loss of what? Of it. Now, because there is loss of it here, now whenever it is lost by the system, it's called what? Negative. So it's always what? Minus, which is what? Negative. Do you get that? Exothermic water reaction because the system lose it, so it's what is always what negative. Then we also have this one here when it is what is gained. Do you get that? When it is gained, it's called endothermic thermic what reaction. You know that there's an increase in what in internal what energy. So there's an increase in what in it. So when there's an increase in it, there is gain. It it what it gain. It what gain. Now whenever there's an it gain, it is what positive. It is what positive. So endothermic reaction is what is it gain is positive. Exothermic reaction is what is it loss is what is negative. So you have to understand this concept very well. So now let's look at what it loss. Now let's look at what this other one here. So if I choose this one here, then it is what is going out, right? So here we can sorry. So here we have what it gain. So it it gain. Now whenever it is gain, we say what is endothermic endothermic what reaction. Endothermic what reaction. Now when it's endothermic reaction, it is what? It is positive. Do you that? Positive. So because there's an increase in what in it, the system gains it, so it's going to be positive. And here the system loss, then the it loss is what is negative. So you have to understand this one here. So we talk about work, work, work done, work done, work done, and it is okay. Work done and what it. So here we have expansion. Expansion which is what is negative. Compression, which is what positive. It's okay. We have what we call exothermic. Exothermic is negative. Endothermic. Endothermic is what is positive. And that if you check very well, they are somehow what related. They are somehow what related. So we have got internal energy. Internal energy. Internal what? Internal what? Energy. It's okay. Internal energy is equals to what? Change what internal energy equals to what? Q plus what? W. So when you sum the heat and work done in the system, it's called what? Internal what? Energy. So this is a general what formula. You get, and when I use this formula here, this as the stuff I want to what consider. Do you understand? So when it comes to internal energy is what is summation of all the possible kind of energy in what is system. So I have to call it our work. So internal energy equals what? Q plus what? W. So you have to look at so many questions on this one here. So let me move on to what? To question. Okay, now let's look at what this first one. It said how much work is performed by a gas as it expands, as it what expand from 20 liter to what 40 liter against a constant external pressure at what 2.5 atm. And I said again is constant external what pressure. So let's solve together. So solution. The question will be here. Then I'll do the calculation. So now V1. Now V1 is what is 20 liter. V2 is what is 40 liter. Now remember, whenever there's an increase in what in the what the volume, it always what expand. When you talk about expansion, there's increase what in volume. So my V1 is what is 20, my V2 is what 40. My P is constant what? Constant pressure of what? 2.5 atm. They talk about the work done. Right there. So they say what is work done. Now remember what is expansion? W is equal to minus P change in what a V. Now what I want to understand is that the final units, like the final answer must have negative. The final answer must have what negative. So let's see if I would have negative here. Remember, they also descend out P times V2 minus what V1, right? So my W here is equal to what? Minus. Now here we have 2.5 atm times 40 minus what 20 liter. So everything here going to be what 50 atm what liter. Just that minus what 50 atm what liter. Remember I told you that you must convert atm liter to what to atm liter to what to joules, right? So how do you convert it? It's very easy. The conversion is very easy. W is equal to minus 50 atm liter times. Do you see that? So here we have 1 atm liter. Then you have 101.33 watt joules. So at atm liter, you consider about atm liter, right? So what will that be your answer? Here we have 506 5066.5 joules. This is not the what? This is not the what answer. Remember, there's what minus here. So there's what minus 506 to the what 5. You can see that it still corresponds to this negative sign. Do you get? Understand that the final answer must have this negative sign. That is what makes the word to expand. Do you see that? So the final answer must correspond. So let's look at question 2. You can see that, look at another question on the board, so you can pause the video and try the question yourself, following step-by-step method of what I've done. You will solve this question here. I forgot, please, if you're enjoying this video, always give it a thumbs up. There's some places that will come and watch, they will not give it a like, and you are benefiting a lot. If this video is actually what benefiting and you're getting value from it, please always like and subscribe. And also tell your friends about chemistry, because this is one of the channel that will actually solve your chemistry problem. I'm going to do my best here to try as much as possible to give you content on chemistry that will actually be of help to you, because I know how difficult and how confusing this concept look like. So for years now, I've been able to help a lot of students to pass their exams. Do you get? So please, I would like you to give it a thumbs up, subscribe, and share with your friends. So please, if you have done that, try do this one yourself. So go ahead and try it. So pause the video and try it. Leave your answer at the comment section. Leave your answer at the comment section. I believe you have done that. Let's look at the solution. Are you there? Let's look at the solution. You see that the mixture of helium and oxygen gas is expanded from a volume. So you have my first volume, V1 equals to what? 56.0 liter. My V2 is what? Is 75.0 liter. Now my P, what is my P is equal to 58.0 atm. That's not of the work done. What is the work done? Now because they say it's expand, what is going to happen? You're going to be what negative. So the W is equals to what minus P change in V, right? Remember this change in V is what V2 minus V1. So let's just impute our value at once here. What my pressure? My pressure is what 58.0 atm times my V2 is what 75 minus 56 liter. So what happened here? Minus 58 atm times 19 liter. So when you sum them together, 1102 atm liter. But understand that there's no way I can live like this. I must convert to what to atm to what joules. So 1 atm liter equals to what 101.33 watt joules. So my work done here is going to be what minus 1102 atm liter times 1 atm liter. Here we have 101.33 watt joules. This will cancel out this one here. So what we want to do is to punch your calculator. So you have minus 11665.66 joules. That is what. That is the what answer. So we are going to try another one. So here we have question 3. Let's do it together. Solution. Okay, now how do we solve this one here? They say that how much work is required to compress a gas from 60 liter to 35 liter at constant pressure of 8 atm. So let's get it together. So V1 now, because they say compression. Now when we talk about compression, the work must be positive. The work must be what? But that is what you want to know. The final answer must be what? Positive. So my V1 is what? Is 60 what liter. My V2 is what? 35 what liter. Can you see that? Then my pressure is equal to what? 8 atm. Can you see that? So now they're asking what is the work done. Now remember, I gave you two formula here. Work is equal to what? Plus P change in V. Now when it's positive is what? Is compression. Compression, right? Then W equals to what? Minus P change in V is what? Expansion. Now remember, if you recall very well, we have been using this formula because they say expansion. So now so many of you will now say you have to use this formula here. W equals to plus P change V, right? But they specify compression. So if you use formula here, let me show you what will happen here. So you have W is equals to plus P change in V. Because it was a statement that said compression. Now, if you check very well, equals to plus uh you have 8 ATM times my V2 is what is 35 minus what? 60 liter. Do you see that? Now, when checking very well, this one will give me minus. So let it be. So you have minus 25. So let it be plus 8 ATM times minus 25 liter. Do that because minus plus and minus will go to my minus. So 8 times 25 is going to be what? 280 liter. But you understand that when you talk about compression, the final this one must be what? Positive. So if you should use this one here, there's no way we are going to get positive as the final answer. We're still going to get negative. So what I want to do here, we are still going to use this expansion work done work formula. So I want to use it means that this one is not going to work until I place minus here. If I place minus here, so if I place minus here equals to minus P change in V. Remember, the final answer should be in positive. Just that. So it's going to be here we have minus 880 times 60 minus what? 60 minus what? 30 what? 5 liter, right? So it will be minus 880 times minus 25 liter, right? It's going to be what? Minus times minus is going to be plus 280 what liter. Do you see that? And remember, I'm going to combine this one here because this positive now corresponds to what? To this positive here. Can you see that? So my W is equal to what? Plus 280 liter over 1 times. So you have 101.33 joules, 180 liter. This will cancel out this one here. What will happen? What will be the final answer? Final answer will be positive here. So here I have 200 times 101.33. So here I have 20266 20266 joules. That is for this question here. So this video has been lengthful, like it's too lengthy now, so I can't go further. So my next video is going to be my next video on thermodynamics is going to be change in internal energy. So I'll change what Q plus what W. This video is already too lengthy, so we are going to end the video here. So how do you calculate change in internal energy? That will be the next video. So that why if you're not subscribed to the channel, please hit that subscribe button, turn the notification bell, always subscribe to the channel, turn the notification bell because when I upload video, you be what be notified that a new video will be uploaded. Do you get that? So I upload video on a constant word basis. If this video is helpful, please I would like to hear from you at the comment section that this video is helpful. Please, now that your comment goes a long way to tell me that you are following. Most of those positive comments I'm seeing on the comment section, those few I value them more than those people that watch this video. Those people that comment on the comment section, I value them more than somebody that just watch and just click away. There's some people that we don't watch, we don't subscribe, we don't like, they just go like that. Please, you are not paying for this content. You get, you are using this content to solve your chemistry issue, and the only way you appreciate a creator is to like, comment, especially when the video is helpful. That's the only thing you can do for a creator at any platform. That's your words of encouragement will make the person to do more for you. Do you get? So if this video is helpful, please leave it at the comment section that this video is helpful and you understand. Thanks for watching. See you in the next video. You can check out any of this video topic you are seeing displaying on the screen and watch this video. I'll see you there.